Hello everyone, my name is Jessica, and in this video I'm going to explain about how I analyze data using Smart PLS, and I'll explain the interpretation. These are the research model that I'm going to analyze. We have 4 variables. The independent variable are extraversions and openness. The mediations variable is financial risk tolerance, and the dependent variable is financial management. First step is I have to import the data to the Smart PLS. So after I got the spreadsheet's answer of the questionnaire from Mr. Adi, then I transform it into extraversion, openness, financial risk tolerance, and financial management like this. Then I save and exported the data into CSV. Next, I'm going to make new project and name my project ALP Jessica. Then, I imported the file to the Smart PLS. After I already imported the data, I can see the mean, median, minimum value, maximum value, standard deviation, excess kurtosis, and also skewness for each indicator. On the next one, I can see the indicator correlation, so it's the correlation between each indicator. For example, the correlation between E1 and E2 is moderate, and the correlation between E1 and E3 is also moderate. Moving on to the next step is the drawing pad. In the drawing pad, I'm going to drag the variable one by one and arrange it. After that, I connect it between variables. Then, I also rename the variables. So now I'm going to check the outer model first. To check the outer model, I'm going to calculate and choose PLS algorithm. And right here, I'm using path for weighting sim, 300 for maximum iteration, and 7 for the stop criterion. So the first step is to find the factor loading, and the benchmark it has to be more than 0.7 and significant. As we can see here, there are green variables which mean they fulfill the benchmark, but there are also a few variables that are red. Therefore, I'm going back to the drawing pad and remove or delete the red variables. Then I calculate again using PL's algorithm. After I calculate again, I check the variable and it all already turned green. Then we check the significance in bootstrapping, and for the settings, I'm going to use the default setting. And as you can see, all of the p-value is less than 0.05, which means significant. The second step is reliability. In the PLS algorithm, I click on the construct reliability and validity. And as you can see, all of the numbers of Cronbach alpha, row A, composite reliability, and AVE are all green. Therefore, the indicators are reliable. Another fact is the value of row A should be between Cronbach alpha and composite reliability. I also check the confidence validity by looking at the AVE. As you can see here, all of the AVE value is more than 0.5. It means all the confidence validity is fulfilled. Next is discriminant validity. There are 3 methods to know discriminant validity, but the most recommended one is the HTMT. Therefore, I'm using the HTMT one. HTMT should be less than 0.9, and in this case, all of the indicators are less than 0.9. Therefore, the discriminant validity criteria is fulfilled. And for the correlation for each variable, I use latent variable, and these are the latent variable correlation. Now, I'm going to conduct the inner model test. The first step is analyze the inner model collinearity. To check, I open the PLS algorithm and click on the collinearity statistic and click on the inner fifth value. If the fifth value is less than 5, there is no multicollinearity, and in this case, all the fifth value are less than 5. Therefore, there is no multicollinearity. Next step is analyzing the direct and the indirect effect in the bootstrapping result. I analyzed the bootstrapping, and now let's summarize what the result is showing. For extraversion to financial management, it's significant positive. For extraversion to financial risk tolerance is significant positive. For financial risk tolerance to financial management, it's not significant. And for openness to financial management is significant positive. And for the last one, from openness to financial risk tolerance is not significant. And for the indirect effect, it already shown from the direct effect that all of them has one of the side that is not significant. So the indirect effect must be not significant. To make sure, I click on the specific indirect effect, and yes, both of them are red. Therefore, financial risk tolerance cannot mediate both extraversion to financial management and openness to financial management. Next is R-square. You can see from the PLS algorithm and click on the R-square. Here, we can see that the financial management 32.3% can be explained by the extraversion, openness, and the financial risk tolerance, while the financial risk tolerance 12.3% can be explained by the extraversion and openness. Next is F-squared. You can see from the PLS algorithm and click F-square. As shown here, on the financial management, extraversion has small effect, financial risk tolerance has no effect, and openness has small effect. While on the financial risk tolerance, extraversion has small effect, and openness has small effect. Last is the Q-square. I calculate blindfolding, and for the setting I use 5 because I cannot use more. The result shows that the financial management has small predictive relevance, and the financial risk tolerance has small predictive relevance as well. It is okay as long as it's not 0. So the conclusions are: first, extraversion has significant effect on financial management. Second, extraversion has significant effect on financial risk tolerance. Third, financial risk tolerance does not affect on financial management. Fourth, openness has significant effect on financial management. Fifth, openness does not affect on financial risk tolerance. And lastly, financial risk tolerance cannot mediate both extraversion to financial management and openness to financial management.